Welcome to week 2. Hope you're doing well. We're going to cover two things this week. First, we're going to install the software program called R and its accompanying MySQL. That's all going to be explained in this course. Second, we'll compare the strategic impact of data analysis across key industries. Thank you again. Looking forward to talking soon. Welcome back, everyone. This is GBA 605 Business Data Analysis and Modeling, week 2. This week, we have two objectives: installing R and looking at the impact of big data on industry. Hi, the learning objectives are basically two things. One is to install R on your computer so that we can run a couple of different cases on there. And the second is the impact of big data on industry. Video on Blackboard that's going to help you install R on your computer. There's a video for Windows users and there's another one for Mac users. So please go to Blackboard for that instruction. So we're getting back to the big topic of the day, and that is big data. Just what is big data and why do we call it big? So here's a definition. There is no standard definition, but this is as good as any. And it's basically saying big data is a data whose scale, diversity, and complexity require new architecture, techniques, algorithms, and analytics to manage it and extract value and hidden knowledge from it. The main thing here is it's a huge amount of data, just an unimaginably large amount of data. And we're able to exploit that today because of advances both in computer processing, which it takes a lot of work to process the data, and second, because of storage capacity and the ability to access a variety of forms of data in a diverse set of locations. So we'll break that down a little bit here. There's three main agreed upon characteristics of big data. The first is scale. Why do we call it big? Because the scale is off the chart. We're talking about new terms like zettabytes that are just, basically sizes of data that we've never calculated before. And every year, more data is produced than in the history of mankind. So every single year, data is piling up on top of data. Some think that our societies will fall under the weight of all this data. Others believe that this data will be able to help businesses to understand their customers better or how their products or services play out in the market and other things. Another attribute is complexity, the variety of the data. So there's many different formats, types, and structures, and also they may be located in various places. Text data, just straight up, just very bare bones text. You would see that in Excel spreadsheet, comma delimited file with numbers in cells. Numerical, generally. Images, very large, complicated pictures today are managed not based on the actual big file itself, but based on an index and a retrieval system, which is very similar to the post office, and that's what we call Hadoop. We're also talking about static data versus streaming data, data that's in place versus data that's in motion. The last thing is that a single application can be generating and collecting many types of data. An example of that would be Twitter, where you as a user are inputting and responding to various Twitter feeds. At the same time, someone on another part of the planet can be interrogating yours and many millions of other people's responses and trying to determine what the meaning. A recent example of that was LeBron James's new tennis shoes. I think I mentioned that in week 1. Nike was able to capture the sentiment of basically consumer response to his tennis shoes very much real time, instantly after it was first released. And candidly, the three that are most established today is speed or velocity, the data that's constantly moving. So it's being generated fast and it is processed very fast. As was mentioned in the previous slide, processing power or Moore's law is always held true. Every 18 months, processing power doubles, and we've not seen a break in that, and nor is there a break in that expected for the next 50 years. So computers are going to get more and more powerful, and we'll see applications like robotics and all those things continue to take off. Online data analytics, Google Analytics is an example of that. So online, you're able to do analysis of data that's out there. So the speed of data is another factor. Some would say there's a fourth, which we'll get to in just a moment. But this is just another construct to demonstrate some applications of big data by size and speed and by complexity. So here's the fourth V, if you will, and it's called veracity, and it kind of touches all the previous three in that it's basically saying that data is very uncertain because it's inconsistent, maybe it's not complete, because it's in so many places and maybe was designed for totally different purposes. So bringing it all together creates its own level of uncertainty because it's bringing it together for a different purpose than it was originally created. And also there's the issue of data governance and who owns it and who has the right to update it, or actually, to be candid, how should the data be interpreted. So that all adds to potentially the fourth V. So harnessing big data, historically OLTP, which goes back to the 70s and 60s, online transaction processing is well played out. And then data warehousing, OLAP, the BI tools, being able to be an end user and interrogate a large repository of data is OLAP or OLAP. And then RTAP is the most recent genre, and that's real-time analytics processing. As I mentioned, Google Analytics is an example of that. But in any case, it's kind of the real-time web-based potential application that gives you, absolutely, as things are happening, analysis of things. We talked a little bit about social media. I mentioned Twitter, but Facebook, YouTube, all those things are generating an amazing amount of data. Your Google search is generating data. There's personalized analysis that's done based on your previous searches. Scientific instruments in the past were hardwired and were tied to things like DEC-VAX machines, and those machines would use programs to interrogate or analyze very specific instrumentation data. But now scientific instruments can interface the cloud, and that data can be accessed by researchers all over the world real time as data is being collected. And of course, your mobile devices, your smartphones, your iPhones, your Droid, all those things are creating a tremendous amount of data. Not just the data that you are querying using applications like Google and such, but also location data, where the devices are, who's using them, and all that is also out there. And then in addition to that, sensor data networks are generating, monitoring and diagnostic and cutover, all those kinds of data all the time. So this amount of data, the amount of data that's being produced or generated is multiple, many times over every single day. So the model of who generates data has changed significantly from a very much proprietary and discrete set of entities, such as large companies that were able to invest into IT infrastructure, and everyone else. So they generated data, and then either the end users or consumers were able to digest or consume that data. The new model is that every one of us is generating data, and every one of us is also consuming data real time. So it's very dynamic, very multi-directional, and large amounts of data passing. Kind of a slide that shows, what's driving big data, and basically it just says, business intelligence, as we talked about, with the database management systems and being able to do SQL or structured query language commands to pull out data from it. That's pretty much tried and proven through the 90s. And then years 2000 and beyond, we're talking about more about predictive analytics and even more sophisticated, looking out towards the future, using very large and very diverse data sets to come up with these forecasts. So the challenges in handling big data are twofold. One is just the technology. The first would be, processing power is, again, that's not been a big bottleneck. In fact, processing power has been increasing very, very smoothly in a positively linear way, and will continue to do so. But also storage capacity is something that's been increasing even at a faster rate, and data storage is getting cheaper and cheaper every year. And so we're seeing those two things that they are bottlenecks, but they're becoming less and less so depending on the application. But the biggest bottleneck is the number of experts that are able to use and support these technologies. I read a statistic the other day that the United States is coming up on about 1 million open job requests for data scientists. If you look at the job boards, they're always looking for people with that background. So it's definitely an opportunity for those who wish to take advantage. So these big data related technologies, and this framework was created by Dave Feinleib back a few years, but it's still relevant, and it's a nice categorization and functional framework to show what technologies are in place and how they're used. And obviously this is just a very small sample of the applications and infrastructure that's out there today, and there's more and more every day, more and more types of technologies. One that's not up there but is growing is NoSQL. So in other words, it's web-based databases that don't require an SQL command language. Their response times are much faster than traditional Oracle. So in other words, this just is a representative sample, a snapshot that's in constant flux, constant dynamics as technology continues to advance, both in the storage and in the processing of data. And it just kind of lays out mainly the applications and by their age and the size of data they're able to handle, and in three different areas. What do we use to handle fast data? What do we do to handle big analytics, analyzing large amounts of data? And what do we do to try and obtain deep insights into what's happening? And along the right side of the business objectives, whether it's R&D or it's trying to look at mass customization of services and so on. But this, again, is just a representative sample which is constantly in flux and expanding all the time. This framework is from the Nesbook book, and it shows the major analytical technique areas such as forecasting, statistics, business intelligence, data mining, and operations research. Some would say that these fields are converging, that they're overlapping, they're beginning to use the same lexicon and techniques. Things are coming together, and there's even tools that are not named here that basically automate a lot of what these tools do or these techniques do, so that you can simplify the user interface and take advantage in the back end of all these different methods. So one thing that's important is to understand what an algorithm is. This definition comes from Merriam-Webster Dictionary. Basically, if you read it the right way, it's like a recipe. If you put together, you want to make a cake, and you buy a Betty Crocker cake mix. It's a set of steps, and when you put them together, the result is a wonderful chocolate cake or vanilla or whatever is your preference. The same thing goes forward in terms of analytics. So in the world of analytics, these are the most effective and the most widely used algorithms. So the top one is decision trees, which you'll see an example of. We mentioned in week 1 about regression, whether it's logit or Poisson. I like linear regression. That's my favorite. Cluster analysis, you'll see an example of that, and so on and so forth. There's Bayesian. See it right there in the middle, 21%. In their use of analytics, I picked predictive analytics because that was what this study was asking about. And it turns out financial services is far and away the largest user of predictive analytics. Is one of the analytics that or results that the industries are looking for. You can see why financial services, whether it be insurance companies or banks or credit card companies, they're always trying to assess risk. They're always trying to look out ahead and see, the profile of, good customers, and can they extrapolate from that and generate, assess new customer leads and see what the potential profitability will be for those customers and make, discounting or whatever kind of decision. So what's happening is that almost every industry is also using those techniques to be more competitive or to stay up with their competition, to assess their performance operationally or looking out over the future. So anyway, pretty interesting. And then I created this framework. It basically disaggregates all data analysis and statistical techniques and puts them into three phases. The first is just reporting, and that's saying what happened. It's anecdotal. It's looking in the past and saying, how can I visually depict what happened? And you'll see some things like k-means clustering and things like that. And then the second phase is just general analysis, and it's looking at why things happen. Why did it happen? And so, like we talked earlier about statistical learning theory in week 1, that's right there in the center. And then predictive is looking out over the future. It's looking at past and present and then making predictions out over the future. There you have Poisson regression, right? We talked about that earlier. Some may agree with this breakdown, but it's a pretty good one. It's a pretty basic one. Data mining tools that you go purchase. R is one that's used for big data. It's an open source, so it means it's free. In fact, you went through the steps earlier to install R on your Windows device. Those of you that are using Apple, check with me and we'll get you hooked up as well. We're just going to install basic R in this class, but these are tools that you can buy or rent that are commercially available both to companies and can be available to academics like you and me. Here's an example of cluster analysis. In this case, we're looking at customer churn, or how many customers are we losing? What are the behaviors or clusters of behaviors and categories? First year attrition, and what kind of money are we getting from them? That's informing executive leadership. Where to apply, various offers and incentives and products that they may either have in place or want to put in place. The second is looking at lift analysis. It's using logistic regression, another one we've talked about, and some different scenarios in terms of what to expect. And this is in just looking at a marketing campaign, what kinds of things, 3 different scenarios, and what could we expect in terms of revenue, who would be buying, the percentage of households that we will be buying over time. And this one is a decision tree. In this case, it's looking at a marketing campaign, and it's looking at years of tenure with a bank. This is a bank and various segments of bank customers, looking at their deposit accounts, based on the campaign, or who we're going after, and what can we expect in terms of return or purchase from those customers. A different form of decision tree. And it's looking at basically a specific marketing campaign and what the breakdown by percentage of different groups that we be making offers to. And here we're showing 7 different groups and 7 different purchase rates and behaviors over time. So that concludes week 2's presentation. Thank you so much for your time and attention. Please feel free to ask any questions. and looking forward to seeing you on week 3. Thank you.